Now, so that we can expand this out, it's important to know the constant multiple rule, which tells us that if we have a function k times little f of x, its antiderivative is just k times capital F of x plus c. That special part of that is the negative rule. That's just making k -1. And the sum or difference rule. So if we have more than one term, we can actually just take the antiderivative of each one of these. Now, first thing I want to do in order to do this one is make this 3x to the -1/2 plus sine of 2x. Okay? Now when we find the general antiderivative, remember what we do is we take our constant, which is just 3, and we're going to say 3 times 1 over -1/2 plus 1 x to the -1/2 plus 1 plus. Now when we did the antiderivative of sine, we did -1 over 2 cosine 2x, and then we'll need to add a constant to that. Now here, this we've had several times before, and we got 2 on the last slide. So this is 3 times 2 is 6. X to the -1/2 plus 1 is +1/2. Plus negative is -1/2 cosine of 2x. We can leave it like this, or if you want to go back to the original notation, that would be 6 square root of x -1/2 cosine 2x plus c. Okay, now here's an application of antiderivatives that has a real-world twist to it. This deals with our position function, velocity function, acceleration functions. And it says a balloon ascending at a rate of 12 feet per second is at a height 80 feet above the ground when a package is dropped. How long does it take the package to reach the ground? So when we start, the balloon is ascending at a rate of 12 feet per second, and it's at a height of 80 feet above the ground when we drop the package. We want to know how long does it take the package to reach the ground. Well, the first thing we need to recognize here is that the acceleration of gravity near the surface of the Earth is 32 feet per second squared. Okay, so that's going to tell us that our acceleration function, is going to be -32. Okay, it's negative because gravity acts in the direction of decreasing s. Okay, so it's a negative acceleration. Now remember that this is the derivative of our velocity function. So we could find our velocity function by taking its antiderivative. Well, the antiderivative of -32 will be -32t. But now we want the most general antiderivative, so we'll put plus c there. Now we do know the initial velocity, okay, and the initial velocity is 12. The balloon is ascending at a rate of 12 feet per second, so that's the initial velocity when it first is dropped is 12 feet per second. So at time 0, which we get by plugging in 0, our velocity is going to be 12. Now -32 times 0 is 0, plus c is just c, so c is 12. So our velocity function here is going to be -32t plus 12. Now we want to find our position function. Now remember, this is the derivative of our position function. So if we want to find our position function, we take the antiderivative, and that would be negative. Now remember, we want to make this t squared. So we're going to do the 32, and we're going to divide it by 2, which is 16. 2 times 16 will give us -32, plus 12t, plus a constant. Now we also know the initial position is 80 feet. That's where we're going to start. So at time 0, our position function, if I plug in zeros, will be 80. Now since this is 0 and this is 0, c is going to be 80. Okay, so s of t will be negative 16t squared plus 12t plus 80. So that gives us our position function. Okay? Now, what does the question ask? How long does it take the package to reach the ground? Well, it reaches the ground when our position is 0. Okay? So we're looking for where negative 16t squared plus 12t plus 80 equals 0. Okay? So I'm going to start here. I'm going to factor out a negative 4, and that will give me 4t squared minus 3t minus 20. And then I'll have to use the quadratic formula since this will not factor. A is 4, B is negative 3, and C is negative 20. Okay, so we're looking at time here. It's negative B plus or minus the square root of B squared minus 4 A C, and that's all over 2A. So that's negative 3 is 3. Negative 3 squared is 9. Now notice we have a negative and a negative, which makes that positive. 4 times 4 is 16. Times 2, or times 20 is 320. All over 8 gives us 3 plus or minus the square root of 329 over 8. Now let's think about times here. If I subtract 3 minus the square root of 329, it's going to be a negative number. So really we're only concerned with the positive. Okay? And if you'll type that into your calculator, it's going to reach the ground at approximately time t equals 2.64. So it's going to take about 2.64 seconds to hit the ground. Now one other thing we need to talk about before we finish up this section is this new symbol. The collection of all antiderivatives of little f represents the indefinite integral of little f with respect to x, and is denoted by this symbol. That symbol is called an integral sign. The function f is the integrand of the integral, and x is the variable of integration. So if we want to evaluate the integral of x squared minus 2x plus 5 d of x. Now it always has this d of x on there if we're looking with respect to x. We are basically, all this means is we're finding the antiderivative. So we've got 2 plus 1 is 3, so we've got 1/3 x to the third minus, now our exponent here will be 2. 2 divided by 2 is 1, so minus x squared plus 5x plus a constant. If I took this derivative, 3 times 1/3 would be 1, x squared minus 2x plus 5 plus 0. And so this new symbol here just means the integral of x squared minus 2x plus 5 dx, and it just means the most general antiderivative of this function.